Hi everyone, in this session we are discussing multiple stack implementation using a single array. That is, how can we implement two stacks into a single array? Means only one array is there and two stacks will be implemented. So while inserting elements in either stack, compare top of each other. So here we have two pointer. Top 1 is a pointer for stack 1 and top 2 is a pointer for stack 2. Both stacks use the same array. So we have two push function, that is push 1 for stack 1 and push 2 for stack 2. Similarly, we have two pop function, that is pop 1 for stack 1 and pop 2 for stack 2. So the question is why we implement two stacks into a single array. So we can say that this is for utilizing memory space, and both stack grow or shrink in opposite direction. So you see here in this figure, the first element in stack 1 is pushed at index 0, means stack 1 starts from index 0 and stack 2 starts from the topmost element, that is the rightmost corner. So the first element in stack 2 is pushed at index max minus 1. So during push operation, top 2, which is a pointer for stack 2, it is decremented like this, and during push operation, top 1 is a pointer which is for stack 2 is incremented. Similarly, for deletion or pop operation, top 2 is incremented and top 1 is decremented. So we can say that both stack grow or shrink in opposite direction. So you see here in the figure, that is for push operation. So first of all, we see here initially both stacks are empty, means top 1 and top 2. Both these pointer, if they are equal to minus 1, then we can say that both stacks are empty. Now suppose we are pushing the first element onto stack 1. So first of all, the pointer top 1 is incremented by 1. So from minus 1 it is now 0. That is, it is incremented by 1 and stack 1 starts from this index, that is 0. So after incrementing this pointer, then we add the item onto stack 1. Similarly, suppose we push item onto stack 2. So stack 2 begins from max minus 1. So after putting this top 2 pointer at this position, we add the item onto stack. So this is for push operation. Again, suppose we push more items onto stack 1 as well as onto stack 2. So top 1 is incremented like this and top 2 is decremented like this. So here in this figure, we have 3 elements in stack 2 and 2 elements in stack 1. Top 1 points at this and top 2 points at this. Now you see here, now because we cannot insert element directly onto stack, first of all we check whether there is a space for the new element or not. So this is the situation where we can say that stack is full if top 2 equal to top 1 plus 1, or we can say that top 1 equal to top 2 minus 1. So this is the situation where we can say that stack is full, means we cannot push item either onto stack 1 or onto stack 2. So top 2 is decremented for each push operation and top 1 is incremented for each push operation. Now next is the pop operation. How we can delete elements from either stack 1 or stack 2. So you see here again the situation before implementing this pop operation. First of all we check whether there are elements in the stack or not. If both these pointer equal to minus 1, then we can say that initially your stack is empty. Now suppose in the next figure you see here that is there are 2 elements in stack 2 and 3 elements in stack 1. So if we pop element either from stack 2 or stack 1, so if we pop element from stack 2, then top 2 is incremented, and we pop elements from stack 1, then top 2 is decremented. So we have to pop element from stack 2, then top 1 is decremented. So after implementing this operation, then top 2 is incremented. Similarly, if we pop element from stack 1, then top 1 is decremented. So top 2 is incremented for each pop operation and top 1 is decremented for each pop operation. So we can say both these stacks grow in opposite direction. Now here you see that is the first push function, that is push function for stack 2, and similarly we have a push function for stack 2. So here you see this push function, it does not return any value. It is similar to the push function like in stack 1. In this we pass one argument. This is the argument, that is the item we want to push onto stack 1. Similarly, the same format for this push to function. So here first of all we check if top 1 equal to top 2 minus 1. So this is the situation where we can say that stack is full. Otherwise, during push operation onto stack 1, first of all top 1 is incremented so that it points to the next memory space, and after that we add the item onto stack. Similarly, if we want to push item onto stack 1, again we check whether stack is full or not. If top 2 equal to top 1 plus 1 or top 1 equal to top 2 minus 1, then we can say that stack is full. We just print a message that is stack is full. Otherwise, during push operation, top 2 is decremented. Top 2 is decremented. Here top 1 is incremented. And after decrementing this top 2, we, so that it points to the next memory space, we add the item onto stack 1. So this is about the push function for stack 1 and stack 2. So here after push operation, that is the next pop operation. So two functions are there, that is pop 1 for stack 1 and pop 2 function for stack 2, and these two function does not return any value, and we never pass any argument inside these two functions because we know that every time we delete the top element either from stack 2 or stack 1. So first of all we check if top 1 equal to minus 1, then we can say that stack 1 is empty, means an underflow situation is there. Similarly we check top 2, if it is equal to minus 1, then we can say that stack 2 is empty. If stack 1 is not empty, then we access the top element from the stack. So this is the way how we can access the top element. After that, top 1 is decremented during this pop operation, and we display the element, that is deleted element from stack 1. Similarly, when we pop element from stack 2, then first of all we access the top element from the stack 2, and after that top 2 is incremented. Here top 1 is decremented, here top 2 is incremented during pop operation. After that we print the deleted element. So this is how we can implement two stacks into a single array for the utilization of memory space. Thanks for watching.